Hi, it's time for another math easy solution. Time to discuss further into the closed interval method for finding absolute and maximum and minimum values. And now to go over a trigonometry example. But first, on a recap on the closed interval method, I went over in my last video. Basically, if you have a closed interval like this, a to b, where closed just means that at the endpoints the value exists on the function. And basically, if you have anything like this, it's continuous. Then the absolute max and minimum values have to be either at the endpoint or at the endpoints or anywhere in between at a critical number, which is C1 or C2 example like this, where the derivative is either 0 or it does not exist. Basically, a recap, and to find it using this method, all you got to do is basically find the values of f at critical numbers basically at the critical numbers in a and b. So you got to find what these values are, and also the values at the endpoints. That's step 2, and then step 3 is basically comparing the steps 1 and 2. The largest of the values is the maximum value, and the smallest of steps 1 and 2 is basically the minimum value. So basically, the max of this is the maximum, is absolute maximum, and the minimum of these points is absolute minimum. So the example I'm going to go over is this one, which states find the absolute maximum and minimum values of the function f of x equals x minus 2 sine x for this interval, which is a closed interval because it can equal at the endpoints. It's just basically x is greater than or equal to 0 and less than or equal to 2 pi right here. So the first step in this, well, we know this is a continuous function because x is continuous, sine of x is continuous, so just the addition or subtraction is also continuous. So basically, the first step in finding the absolute maximum minimum, is basically finding the values of f at the critical points. And to find the critical points, we have to first find the derivative of this function, which is going to be f of x equals 2, 1, derivative of x is 1, minus 2 times derivative of sine, which is cos x right here. So it's cos of x, and now as you can see, cos of x is continuous, and so there is no sharp corners, or the derivative exists at all points. So the only place you have to consider for critical numbers is when the derivative equals to 0. So we set it to equal to 0, 1 over 2 cos x right here. So solve for cos of x, we get basically cos of x equals 2, 1 over 2 right here. So now this, we could actually use our exact trigonometric ratios, and basically with this cos x equals 1 over 2, if you recall my earlier video, I went over exact trigonometric ratio. If you were to draw a triangle like this, and this would be, let's say, this right angle here, so this is going to be a 1, so the ratio of cosine is basically adjacent over hypotenuse, so 1 over 2, and this value is going to be square root of 3, or 4 squared, or 2 squared minus 1 squared, which is going to be, and then square root of 3. So this value right here is actually pi over 3, and that's what this x value is. So basically, this absolute trigonometric function, this is going to be a pi over 6. You can make sure to watch my earlier video to get more info on this. So this angle is pi over 3, and this corresponds to x right here. So we know that according to this exact trigonometry ratio, we have x equals to basically pi over 3. But remember, trigonometry functions, or trigonomic functions, are periodic, so this is going to go up and down, so we can have multiple values of x right here. So to do this, to find out the other values of x, or if there is, because we know this is a critical number because of this exact trig ratio. So if we were to graph cosine like this, we know it's going to look something like this. So this is how cosine is from basically from 0 all the way to 2 pi right here. So we know that this is a critical number, pi over 3, and this is whenever cos x equals 1 over 2, the derivative is going to be 0 of this function. But when we look at only cos x right here, so we'll just point out this is cos of x. So we have to find out when it's going to be equal to 1 over 2. And so as you can see, there's going to be 2 points. So this is when y is 1 over 2. So we know this point is pi over 3, because we know this is, at this point is going to be pi over 2. And then this point right here is at pi. This is 3 pi over 2. This is 2 pi. So now this point right here, this has to be this pi over 3, because there's going to be 2 points. So this is our pi over 3. So now we have to find out what this value is. And we know that since this is symmetric, from here to here is pi over 3. And so is from here to here. So this is just pi over 3. So we can find out what this point is. Basically, we can find out this is going to be 2 pi minus pi over 3. Because 2 pi is from all the way from here to here. So minus this little section, we're going to get now using basically using common denominator, multiply this top by 3 and the bottom by 3. We're going to have now 6 pi minus pi over 3. This is over 3 here. So then this next value is going to be 5 pi over 3. So our critical numbers are x equals 2 pi over 3 and 5 pi over 3 in this interval. So we got these values right over here. So now in the step we have to find out what the function is at these values. So f of 3 and f of pi over 3 is equal to, this equals to, just plug into the function, which is x minus 2 sine x. So it's going to be pi over 3 minus 2 times sine of pi over 3. So this equals to basically pi over 3 and then minus 2 times. Now this one we could use that exact trig ratio. If we go back up to here, the sine of this pi over 3 is just going to be, well, square root 3 over, so opposite over hypotenuse, so square root of 3 over 2. So we get square root 3 over 2, and this equals to basically pi over 3 minus square root of 3. And if you were to plug this to the calculator, you get basically about negative 0.648. So you get a value like this over here. So now we plug in the next one, f of 5 pi over 3. So we plug this in, we're going to get 5 pi over 3. Now minus 2 times, now we have to do the sine of 5 pi over 3. So now remember, with trigonometry we have to look at what this value is going to be, because we have to use exact ratio, so we know it's going to be square root 3 over 2, but we need to see if it's going to be positive or negative, because, well, we have to look at how the function looks like. So if you were to graph sine's going to be like something like this, all the way over here from 0 to 2 pi. So it goes from 0 here all the way to 2 pi, and as you can see, we know that at basically 5 pi over 3, at 3 pi over 2, if this is pi over 2 right here, we know that 3 pi over 2 is somewhere over here, and everything above here is positive, but then the 5 pi over 3 is going to be somewhere over here. It's going to be the same ratio, except then it's going to be negative here, because it's positive here and it's negative everywhere here. So this would just equal to, if we write this down, I'll just drag an arrow right here, equals to 5 pi over 3. Now minus 2 times it by negative square root 3 over 2. So now that's the only difference here, is going to be negative. So now this will just be now positive right here, or we get 5 pi over 3 plus the 2's cancel, square root of 3. If you were to plug this in the calculator, you would get about 6.968 right here. So now we have step 1 down, so now we go step 2, find the endpoints of this function, and this is from 0 to 2 pi, so we just got to plug this inside this. So we get f of 0 equals to 0 minus 2 sine of 0, and like I showed in this graph of sine of x, it's 0 here, and it's also 0 at 2 pi. So we get basically 0. And now the f of 2 pi, this will equal to, so 2 pi minus 2 times sine 2 pi, and like I showed above, sine 2 pi is just 0, so this just equals to 2 pi right here. And if you plug that in the calculator, it's about 6.28-ish, or something like that. And now basically the step 3, which is comparing the values of step 1 and 2 and seeing which is the highest and lowest, or absolute max minimum, and in this case absolute maximum is going to be the highest point, which is f of 5 pi over 3, and that's about 6.968, and the lowest is f of 5 and f of pi over 3, which is about negative 0.648, and as you can see here, so then the endpoints don't have the absolute max or minimum. It's going to occur at these critical points, which is over here, 5 pi over 3, this value, and also at this point right here at pi over 3. And now as a check of the work I have graphed here with Google Graphing Calculator, the function, as you can see, basically at this pi over 3, which is close to 1, because this pi is close to 3. So as you can see, this is the lowest point right here. And at 5 pi over 3, which is once again close to 5, it's going to be the highest point over here, and it's about 7. So it's about 7. This one's a negative value, which is just a bit less than 1 over negative 1 over here. So you see that's the value here, and at the endpoint, it's not the highest or lowest. And anyways, that's all for today. If you learned from this video, you could also download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.